Your test's gonna have some conjugate, i's, radicals. This is not only part of the test. This is probably the second part of the test that you guys need to get familiar on. So let's start with the question. Which question we go over? Brandon? 11. Okay, I hear some 11s. So and you might want to write down 11. 11 is a to the negative 1 minus 2a to the negative 2 over 2a to the negative 1 plus 2a to the negative 1 like this. Now, we talked about yesterday that a to the negative 1 does not flip to become denominator. It becomes its own fractions. So what I mean by that is this does not go all the way down. It's just going like this. And hopefully your first step is correct. Do that first step, okay? Now I can go through the short way or long way. So let's go through the long way because I feel like long way is more steady. That you're gonna get the right answer. Doesn't matter. You need to combine fraction because this is a parenthesis. You need to combine fraction. This is parenthesis. So then you're gonna have a to the a minus 2 divided by 2a of 4 minus 1 is 3, right? Yeah, because 2 times 2 is 4. Now, since they have same denominator, it's going to be 4 minus 1. So it'll be a minus 2 over a times 2a over 3.
I think you're
Which part?
the denominator.
Bottom?
Yeah.
Okay, so that's 5, right?
Yeah.
So that's 5. So this a cancel out. So it'll be 5, 2 times a minus 2. It doesn't take long.
For the a minus 2 over a, pretty sure it's supposed to be a minus 2 over a squared.
Nope, you're right. So therefore, it's going to be 2a, right? Is that better? Oh, no, wait, hold on a second. Let me make sure again. This one is a square here. So that is going to be, give me a second. Doing too fast. It's going to be 2a minus 2 over 5a. That's what you got? Okay, good. Yes, Ashton. Make sure you got through the first part, second part, and the rest of the part is same as anything like before. Now this is start getting harder. It's not that hard. It's just like a combine fraction, divide fraction. It's not. It's same thing that what we did before, but just with expressions. Next question. Yes. 5. Because now you have a same denominator, 2a, right? So this 4 plus 1 is 5. Because you have same denominator, you can add now. Yes. 8? Okay, sure. 8 is the same thing. Can you do it? Same exact thing. Well, why don't you tell me what to do?
Well, I'm doing the 1 and the y over y.
Y over y, good.
The other one is the y squared over y squared.
It seems about right.
Just like did the subtraction, so y minus x over y.
Doing good.
And that over x squared minus y squared. over y squared.
Perfect. What do I do next?
I did the keep change flip.
Okay. And this becomes keep change flip. And this is x plus y and x minus y. Did you see that? It's a difference of a square. Okay. So that's x squared minus y squared. That you gotta see that's difference of square. Now, if you realize this is a y minus x, and this bottom is x minus y, so you can change the order by factoring out a negative sign. So that's going to be x minus y over y. It's not times. Negative over negative. Just factor out. So you can change that order. Y squared of x plus y times x minus y. So now x minus y can cancel out. This can cancel out. That's going to be negative y over x plus y. Yes, Grace. Somebody, Ian was asking this question. Yes. Because y minus x and x minus y cannot cancel. So if you have y minus x, this x minus y, they cannot cancel. What you can do is you can change the order of thing by factoring out -1 times x minus y over x minus y. And that will cancel. That's going to become -1. And if you don't understand, you got to write it down. X plus y over x plus y can cancel. Or x plus y over y plus x, that can cancel. But y minus x, x minus y, since they both are negative sign, but they're different order, you have to factor out -1 on numerator in order for you to cancel. Next question. Yes.
Could you go over
3, sure. 3 is one of the question that you need to factor everything. So I don't like this thing here just because this is not descending order. So what I'm gonna do is I'm gonna do this on the side. I'm gonna change that -12x squared plus 18x. Is that okay? So I'm gonna look at a factor of that. What's the factor of -12x squared plus 18x? -6x. Good. So then, do you see that? Because 12 and 18, and then that's gonna give you 2x plus 3, I believe. Let's see if I'm doing anything right here. Am I doing okay? Huh? Is it, huh? Oh, 2x minus 3. Oh, yeah. See. 2x minus 3, sorry. Oh, going too fast. 2x minus 3, not 2x plus 3. So now on the bottom, if I factor use a box, that's going to be 2x plus 1. This actually is called perfect square trinomial. And on here, I have no idea what a factor is. I need you guys help me. What's the factor of that? Well, 4, 3, 8. So 2, 2, 3, 1. So it'd be 2x plus 1 and 2x plus 3. Is that okay? Like this, and this like this, and this like this. And the answer is -6x over 2x plus 1. Yes. -12. Same thing like any other questions. I'm gonna say 3 over y plus 3 over x, my bad. 3 over x plus 3 over y. In this question, I believe I write it wrong, but that's okay. X squared minus 9 over y squared. I need a combined fraction, so I need to multiply this by, well, this is this. I need to multiply this by x over x. This is y over y. So then I will get 3y plus 3x over xy over y squared over y squared, x squared over x squared. So that's going to be 4y squared minus 9x squared over x squared y squared. The bad thing about, I did write this question wrong because this is supposed to be a 2, but that's okay. Still something can cancel. So 3y plus 3x over xy times x squared y squared, keep change flip, 2y minus 3x and 2y plus 3x. And unfortunately, this is cancel. So you're left with the xy times 3y plus 3x over 2y. Wait, hold on a second. 2y minus 3x and 2y plus 3x. And if that's a 2, then you would be able to cancel if I write this number correctly, but I didn't. And there's nothing I can do from here. I mean, just combine fraction, simplify fraction. I don't know, like, it's the same thing repeating. And if you guys have to check your answer through Photo Math or Mathway, that's fine, but you just cannot rely on it. Cannot just look at it, oh, I know how to do it now. That's not gonna cut it. You really have to try to figure out, and then you walk all the way to the end, and you got an answer, and then go check the answer. If the answer is wrong, then that's fine. That's the time to go find out, okay, which part I make mistake. I don't know if you guys remember AJ Teacher. He's always like telling me like how rich he is. That's like you guys know him. He's like, I got premium version of Mathway. I'm like, okay, great, good job, good for you. Yeah, but he was a jackass. Yes.
Could you go over number 5?
Number 5, yes. I don't know. I won't be proud to flex premium Mathway. That's just me. All right, so this part here, again, descending order. So let me change that. So it's negative x squared plus 3x, I think. And I can factor out a negative x, and that's going to be x minus 3. Is that okay? On the bottom is a factoring the cube. So it'll be x minus 3 and the x squared. If you know how to do the SOAP, which is on your last test, that should be plus 3x plus 9. And this is going to be x squared plus 3x plus 9 over x. So this whole thing actually cancel out. And this whole thing is actually cancel out. Oh wow, this is also cancel out. This is a negative 1. It's a pretty nice problem. Everything kind of cancel out. Those of you who don't know how to factor the cube, you need to know how to do that. Because this is a cube, this is a perfect cube, this is a perfect cube as well. And I see I go wrong, everybody messed up the first one, which is I was kind of disappointed because that is going to be the cube. So you can say a cube equal to ax cubed. A must be 2x. B to the cube equal to 125. B is equal to 5. So that's equal to a minus b, I think, in a squared, so it's going to be 4x squared. ab is going to be plus 10x and a plus 25 all over 2x. Wait, this is 5, right? 2x minus 5. And this will cancel out. Left with a 4x squared plus 10x plus 25. And that's that.
Can you zoom in on for number 5?
For number 5, -1. Just factor in the cube. Pretty much this test is about factoring. And can you do conjugate? Can you do in things? Can you do I? And also the problem is going to be up to your speed. Your speed is, like right now, is not able to finish all the problems. That's something I'm more worried about. No other question? Is good? Yes?
Can you do number 9?
Number 9, sure. Whatever. Number 9. Number 9 is good. I like that question. Number 9 is, the problem is there's a fractions here. There's also fractions here. So I'm going to multiply this by x minus 2 over x minus 2. And then what happened is you're going to get x minus 1 over x squared minus 4 divided by x minus 2 minus 1 over x minus 2. So that's equal to x minus 1 over x squared minus 4. And keep change flip, this is going to be x minus 2 over x minus 3, I believe. It's minus 3, right? Okay. And then this can be factors, so I'm going to change this to x plus 2 and x minus 2. And the x minus 2 cancel out with this. And you left with the x minus 1 over x plus 2 over x minus 3. And that's probably as much as I can simplify. And I always leave in the factor form. I do not distribute because a factor form give you a lot of advantages. And what I mean by advantages, you can find vertical asymptote, you can find y-intercept, x-intercept much better, much faster, rather than that.
Could you just read number 12?
12? 12 is a bad question, but the answer should get x y over 3y plus 3x over 2y minus 3x, 2y plus 3x. Because the numerator is supposed to cancel out. If I write out correctly, that's 2. That it would have been canceled out, but this is not. It was 3y plus 3x. And question 30 is also on the test. Hopefully you know how to do that now. Do pen order operation first. Let me make sure you get it right. So that's going to give you 8 x to the 1, I think.
Yeah.
Y to the what?
2.
2 over negative 2/3. So everything is negative. So it's x to the negative 2/3, y to the negative 4/3, 8 to the negative 2/3, and that's equal to 4x to the 2/3, y to the 4/3. And that question will show up again, just because I really believe in a strong exponent rule. It's gonna help you on so many ways, especially your next year calculus. Like people, I always think about exponent rule is easy, but the problem is people always get it wrong. including myself as a student. So you cannot just say, oh, I know how to do it, but you don't, because you don't get a right answer. You have to get a right answer in order to really know what you're doing. Especially a question like this. At fractions, you can practice learning how to subtract fractions, subtracting negative number, adding negative number, multiplying negative numbers. Yeah, that's fine. Yes.
On the test, we have to put it into a radical.
Nope. Leave it rational exponent. The reason why you want the rational exponent, that your whole next year is going to be living in the rational exponents. No more questions? Okay, let's write down what's on the test. I'm thinking whether should I do test Tuesday, but if I don't do test Tuesday, because usually long weekend people forget stuff and they don't have time to go over it. So I'm changing that to Thursday. However, on Tuesday, I'm teaching something new. So I'm still covering something new. You can come after school, try to get better on whatever it is. So I'd rather you have prepared better than anything else. So yeah, what I'm gonna do is actually I'm gonna I'm gonna write out the test review here. I'm just based on the questions. Hold on a second. Let's see. It's not printing. Not cool. Oh, okay. Okay, on the test, you have to worry about certain things. So let me print up. I'll write down similar questions for you guys. Okay. On the test, you are gonna have a question looks like very similar to like this. I think. Oh, sorry, that's really similar to your homework. You're gonna have questions similar like this. You have questions similar like this. You do have questions similar like this, subtractions. And you do have question looks like something like this. Something like this. And you're gonna have more question like that. So 1, 2, 3, 6. That doesn't mean all the questions not important. Every other question is a practice factoring, but you're gonna see probably something like that. All right, let me write down what other question you might have for test review. you will get that very easy, like 2 plus 4i, 6 minus 2i, something like that. Rationalize. So do you know how to do that? Yes? Anybody don't know how to do it? Okay. Charlotte, do you remember how to do it? Can you help out? Okay. Anybody don't know how to do this? Okay, let's give it a try first. Give it a try. I'm gonna write down a problem. I give you guys a try. Second problem is probably rationalize this. You got to be rationalize something like simple. All those are rationalized. You have all this rationalization. And you might have to deal with radicals. Simplifying this. So this I'll simplify. That's on top of question 7. What is I to the 271 power? 8. What is square root of negative? Remember, you can square root negative number is kind of tricky. So square root of 6 times square root of negative 12. That's kind of tricky. Be careful. 9. A question from before. 6x to the 4th, y to the negative 2 minus 2x squared y to the 4 negative 5 plus 8x to y to the 4th all over 2x to the negative 2 y to the 5. Do you know how to simplify that? Split all of them? Sure. So your test will not be on Tuesday. It will be moved a little bit, but doesn't mean anything. That means Tuesday I'm teaching something new. Wednesday I'm teaching something new. So you have as many time to actually go over the skills. And some of you guys need to go back to algebra, go into the first test skill. So I know, yes.
Use your shoe.
Yeah, are you okay? It sounds like it. And like I said, I really like those type of questions that you have to know your exponents. So 16x to the negative 1/2, 2 x to the 7, y to the negative 1/3, y to the 2/5, to the negative 5/3. So something like this, you will see it. Yes, I can count. I'm serious. I have problem lettering, I have problem counting. So this is whatever is not on yesterday's homework that is also on the test. I'm going to talk about one last thing about complex numbers, so but we'll talk about it tomorrow or next time. So help out each other with those 10 questions. Yes. 10? Sure. It was 16x to the 1/2, x to the 16x to the negative 1/2, y to the negative 1/3 over 2x to the 7, y to the 2/5. The whole thing is negative 5/3 power. What? How'd you get 64? I don't think the 64 is the right number. Yes, Bonnet. Which one? Question 9?
Yeah.
Y to the 4 at the bottom, at the end?
Yeah.
Yeah. So let's start with those 10 questions. Help out each other out.
So you find the conjugate of the bottom, which just do. Basically, this is 6 minus 2i, it's just 6 plus 2i. So you switch them. Yeah, why do you want to do that? Because you can't leave. Oh, well, it'll make you. And I is basically radical. You can't do it. Yeah, I got it right. Yeah, I is yeah. So
3 what?
you get 3b to the bottom and the top.
The problem is there's radical on the bottom. So there's radical from 2 and radical 5. And that's easiest question.
Yeah.
You just have to rationalize it.
Mine is 8i over 40 minus 1. I finally was 28i plus 4 over 40.
You had to split them at the end. Yeah, you had to split them at
Okay, no, because it is 28 plus 1. No, you're right, it's split. It's 28i plus 4. You're right, but then you could also multiply it to 7i plus 1 over 10, can't you? Or am I wrong? 7. 28 and 4. Can't you divide the whole top by 4? Because you can divide 28 by 7, you can divide 4 by 4. Yeah. Okay, but I did forget about the splitting part, so then you got it right. There. But then I put the wrong sign. Yeah, so 7i over 10 plus 1 plus. Okay. I know, I did 2. 2 is the
yeah,
conjugate. Here's a good one. Okay, so 3.
I mean, I would attempt to if you don't actually use the square roots.
Well, if
Yeah. I need you to write down all the questions though. And I'll give it to you.
Okay, wait.
I will put it on the WhatsApp, so you don't need to write down the question. I will post more questions after this too.
It's like the 8 from
Yeah. Wait, it's 3?
Yeah.
No, but I think the conjugate on the bottom because the conjugate will always be different. You can always go like a squared minus b. If it's easier for you. If it's not easier, then just do distribution. But for me, it's easier to do different squares.
Wait, what do you
Yeah.
Oh, wait, time.
So, yeah, I would think about that. Okay, so if you times root 6, you'll end up with 3 minus 12 over 6. So would you get you can also by 12 to 2 big, and then you have 2 on the outside,
So 6
on the inside.
over 6, right?
6 root 3 over 6. Yeah, I think so.
And then same thing, so 6 minus 5. So that's 10, that's number 5. Very good. Yeah.
It'll be 6y.
Super 10.
No, but look at Wait, I'm gonna spend my time writing down your questions because I didn't write down.
You don't need to write down the question. I'll post on WhatsApp. I will post more questions too, just for you to review.
Root 2 over 5 is the same as root 2 over root 5.
When you get to the unit,
You're right. You're right.
there's only one. There's 5 2's and no over.
So we just got multiplied by 5 and 5.
Yeah, exactly. And then you can't simplify it.
Number 2. Okay, so again, it's since you find the complicated, so it ends up becoming. Okay, so one thing you can do first is you can get rid of the 12. You can bring out the 2 to the outside, and then you have 8, and then you keep the 3 inside. The next thing you do is then you find out. So then you square 8. Square the 8.
So you think about it,
And you do minus square root of square root 2, which is 4. And then you divide it into 5 squared. So then it's going to be 64 times 3 minus. So it would just be 192. That goes up to awesome. On the top, it's 5, and then it's going to be
I'll distribute it. I mean, like that 8 square root 60. Did you like?
yeah, the only thing is right here, it's I squared. I squared is
2 root 5 distribute 8. So that's
you can keep it by the negative 8 here.
which gives us 8 root 3.
It's not 4 root 12, it's 4 root 3.
Oh yeah, I forgot. I didn't. I mean, I'm sure we'll probably get it. I just didn't do
So you know how you got I squared here, right? I squared.
You have to be there to because the way I did it, you should
And
end
so
up with
if the I
170.
squared is going to be 8, you make do 8 times negative 1. You make 8 times 1 and since now this is
And
just
at the top is just easy distribution, and you split up. That's the part I always split up.
and then same thing with the
Yeah. The test is definitely like split it up, right?
All right, so on the first question, make sure you split to A plus BI form. Okay, I'm gonna talk about that on Tuesday for like briefly 10 minutes We'll talk about one more question that's on the test. Why you switch to A plus BI form. Now, I will post a second page of this test review, just kind of give you extra questions. So make sure you go over over the weekend. Make sure you do all the questions, understand how to do all the questions. Come after school. If you need help, please come after school. Layla? No, I know you did. I saw you. I saw you on top of thing. Good job. Yeah, you will learn that later. Except you have to do it in like 6 minutes. Bible. Hi, Sydney.
Not sick. I just don't feel fever or anything.
Huh?
I don't have a fever or anything.
There's a lot of things going on. Me, like, don't get me.
Who do you throw the basketball? Last night.
No, he won't know. On a chair. Yeah. On a chair. Yeah. Guys, I'm not trying to get out. There it is. Put on this whiteboard. I feel like I'm gonna get screamed at. No, I'm gonna set it right here and tell them not have them based on your desk. You like if I'm about to end this class, hopefully he notices. Yeah. Okay. Yeah, like your decoration. Mr. Yeah, where'd you get that from? Okay, it's your side.
Dude, 1 minute remaining until class.
Do you mind if I put it there?
Established at 2023.
I got inspiration from your Mr. Lisa game that. I got info from that, so I was like, yeah. Oh, we have
And if you need a sign at your house, just let me know. So yesterday, just doing thing numerically. Why so many absent? I feel like.
Where's Kevin? Kevin was here today.
No, it's like I think a lot of people are sick. Well, she's not. She's in Texas. Wait, is that missing one student over there? Huh? Simon. Oh. That kid always absent. Starting early this year. And who sits here? You don't know? Who's your group leader? Nathan.
Yeah.
Is he here? Huh?
No, he wasn't here.
Oh, he got a lot of people are sick though. Okay, yesterday just a numerical approach. You just pretty much plug in decimal, see what happened. And Greyhound, she ditched you. She's like, let me get my bag too while I'm at it. Let me run away as far as from Greyhound as possible. All right. So today is gonna be beginning of calculus. Yesterday just kind of let you see different things. So let's review. What's three situation that limit does not exist? That's one of them. Unbound behavior, that's asymptote. Okay. What else? Yes, Omar.
When the limit from the left is not equal to the one from the right.
Okay, so that's a very important one. That's always tested. The first one's always tested. Oscillation almost never tested. I do, but never tested on AP exam. Because a lot of people don't even teach it. I teach it just because I actually enjoy that part of math. But yeah, so today we're gonna talk about how to find things algebraically. Now I'm gonna come look at your homework. Make sure you do your homework because a lot of time, if you do your homework, there's a lot of perk to it. Well, first of all, you gotta get better test score. Second, if you didn't do your homework, I won't allow you to retake a test. So some things like this, I'm just gonna now. I don't give retests all the time, but a lot of tests probably will. Not all the time. Some tests I won't give retest. Some tests, like I see like the score is relative on the low side, I will let you retake it. But then if you didn't do your homework, then there's nothing I can do for you. So simple things I ask is make sure your homework is always on top of it. You know, even though like yesterday's homework is pretty, it's kind of like feel like it's kind of busy work, just kind of plug in a number. But at least I want you to get a sense to go into the field the number that is changing and go into a certain number. That's very, very important. At least most of you guys never experienced that before. So you need to understand how the number is changing. So even though the work is pretty easy, then you should go do it. Okay. You should not have any questions, right? Do you have any questions? Do you tell me what they reached to though?
Oh, no, I just.
What they reached to? They reached to the 0?
I think that's 100%.
Yeah. You gotta tell me what they reached to. That's the second time.
Introduction only. One permission.
Okay, I want to teach it.
I didn't.
There you go. That's good. So hopefully you can see the number going from one place to the other place. Okay, only Rayhan. I'll fight you. And trust me, I'll bet money on myself. What did they say? LeBron James said once, or somebody said once. If like it says, if you see me get in a fight with a bear, pray for the bears. Ray Hung, I can kick your ass. Huh? Simon, show up to school on time, sir. You just wake up, you can tell. Are you as bad as Austin? Oh, you're worse, probably.
Depends on the game.
Oh,
Austin's way worse.
Austin's worse.
Hey, Austin's way worse. Having second period for bio last year, he showed up 50% of the stuff.
For the first like week, first 2 days, he was like 50
I'm glad I have Austin at 7 period for
He had
years.
I think he reached like 150 times. Or no, or like no,
absences.
80 absences.
So the section for the calculus part, at least let me give you some answers. Well, most of them you can find the answer on decimals, but 15, the answer is 1. 17, wait, Simon, did you do homework?
I was gonna ask you.
Okay, come here, show me. Okay. Yeah, you gotta plug in a value more. Okay, so from 15 on, the question, when you reach 3 is equal to 1. 17, when you reach 2, is going to be 2. 19, when it reached 2, is going to be does not exist. 21 is going to be 0. And 23 is going to be undefined because oscillation.
Isn't 23 not no solution because of oscillation?
Yeah, it does not exist.
I said it's undefined. Isn't that
Just same thing. It just does not exist. Undefined is fine. Both answer, I'll take it. Yeah, not big deal. I'm not gonna worry about that. I can call it. Usually we say it does not exist. It just because the limit does not exist, not undefined. So it does not exist. It will be a more appropriate way to say it. Undefined is also fine. It's not wrong. Yes.
So you know how 15 it crosses the point
Yep.
and starts?
Mhm.
So wouldn't that be considered no limit? No limit?
15, no, when they go to 3 from left to right, they all reach the y value of 1. Now for 17, they both reach 2, even though there's a black dot right underneath it. So limit still exists at, and limit x approach 2 is equal to 2. And we're going to talk about a little bit more about that. Questions? No? Okay. So today we're going to be able to tell graphically. Graphically is super easy. It's one of the easiest part, but it's also very easy to get confused. So what I'm going to do, I'm going to draw a graph out. And I'm going to make this graph. And hopefully you can draw a very similar graph with the grids. It's always nice to have graphing paper in this class. If you're not, then you can take a picture of this graph and then that'll be easier. So the first part of the graph is going to be something like there is a asymptote going through this way. So there's an asymptote, and there's an asymptote here. Okay, so this is going up, and this part is going to go here and go in here. And I have a black dot right here. Had here. So the graph's gonna look like this. Let's see what else I did in Kuru. So if I have a function look like this, and obviously, so you can take a picture if you want, so that way you can see that. So the first question I will ask, so I will ask a lot of questions. This is how do you analyze limit using graphic approach? Look at the pictures and decide that. So you can take a picture of that. So the first part I will say is, hey, what happened when limits x approach to, let's say, -1 on the left side? Okay, -1 from the left side. What do you guys think? Yes. -1 from the left side. So what do you guys think? What?
Because that's the what a circle point is.
I don't know.
Wait, is there 3 solutions?
There's only one solution. So those of you guys don't know, that's okay. But Kevin was right. It was 2. Why is 2? Because if I use a if I use this thing here, so if I going -1, this is a -1, right? Now I'm only approach from the left. You see this is going to value of 2. Is that okay? Because you're going from the left end, you're going toward here. And that's the value of 2. Even though it's open circle, it doesn't matter. Limit can find the open circle, right? They can reach that, that's it become equal to 2. However, let's try this again. Let's try second question. How about limit x approach to -1 from the positive side? Any other people? Yes. Alvin?
4.
It's gonna be 4. Is that okay? because I'm reaching from this end. And I'm going here, and that's reaching 4. Is that okay? All right. Third thing. How about what is f of -1? What is f of -1? Omar?
That just be negative.
Yes, it's the black dot. So you got to understand limits and the evaluation at a certain number are completely different. The evaluation at a certain number is based on a black dot. Okay?
Yeah, because that was confusing me.
Yeah, so that's 1. Is that okay? Does that make sense? For -1, you're right. 4. How about limit x approach to -1 of f of x, if this is f of x?
What?
What about limit x approach to -1 of f of x? Yes. Why is it undefined? Good job, Alvin. Ah, the left side does not equal the right side. 1 is equal to 4, 1 is equal to 2. But every time if I check out one particular number, you should think about it from both ends. Left and right are reaching the same number. If they're not reaching the same number, they are undefined. If they reach the same number, then it's going to be exist. And that's going to be the output. Okay? Does that make sense? So 5. I can ask you, what happened when limit x approach to 1? What happened when limit x approach to 1? Sashaf, what do you think? It will be undefined. Good job. Why do you think it's undefined? Right, that's awesome. At 1 here, that does not equal to the same value. That's very, very awesome job. Okay, 6. What about f of 1? That's as Vanessa. F of 1 is what? F of 1 is not 1. Ria? What's f of 1? F of 1 is not undefined either. Adam?
It's 2.
2 is correct. Because look for the black dot. When the x equal to 1, the black dot located at 2 instead of 1. Do you see that, Ria? Question 7. What happened limit x approach to -4 from the left side? Rehan, what do you think? -4 from the left side.
-1.
Nope.
0.
Nope, you're guessing. Let me ask Lyndon. Nope. Omar?
-3.
You're on the right track, but no. Laxmi, what do you say?
Said positive infinity.
Positive infinity is good. Because this is asymptote. If it goes asymptote, they had to go straight up. So it's a positive infinity. Now, why it's not negative infinity? Because we are approaching -4 from the left side.
Oh, okay. I thought it was on the bottom.
No, because there's a negative sign here. Yeah, from the left side, it's a positive infinity. Okay, 8. What happened limit x approach to -4? Simon? Negative infinity. No. Kevin?
I was about to say the same thing, but do that. Does not exist.
Does not exist. Why?
Because this is an asymptote.
That could be a reason, but that's not entire reason. You should be looking for the first reason. Limit approaching -4 from the left side is positive infinity. Limit approach from the right side, positive side, is going to go negative infinity. Therefore, if I ask you a one particular number, you should look from both ends. They don't come in the same conclusion. They don't exist.
It's going towards an asymptote that doesn't exist.
If it's going toward this one, it exists, will be negative infinity. But some people can say does not exist, but just not going to be negative infinity. Does not. I will say it's, if it's one side limit, I always choose infinity or negative infinity. So in this case, it'll be does not exist, because if you look at -4 from the left side and right side at the same time, one's going past infinity, one going to negative infinity. Is that okay? Okay, number 9. How about limit x approach to -3? Hold on, let me call Sarah. I can never see Sarah's face. Hi, Sarah. What? Nope. Sydney. Nope. Yuri. Zero is good. You should be confident. Yeah, 0 is good, because why? If you reach from the both end, they have the same output, which is 0. Do you see that? And that's how you determine the using limits. Is that okay? Okay. Let me ask you 10. What is f of 5? Shang? 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 F of 5. F of 5. No. Sophia, what's f of 5? Can you see? No. Melissa? What? Is it 0? No. Is it what?
Undefined.
Why?
Because the right side isn't.
No, that's not a reason. It's a right answer, but that's not a reason. Kevin?
Because like it just doesn't exist on the y-axis.
Y-axis? No, that's not a right reason. Alvin? It's an open circle. There's no evaluation.
So if you set f of x equal to anything, and if it's not a closed circle, if it's an open circle,
It just, there's no value.
Yeah.
But limit does exist though. Look at this. F of 5 is the undefined, right? It does not exist, right? And then, or undefined, sorry. Either one is fine. Now, what happened if I ask you limit? What happened limit x approach to 5? And didn't this confuse heck out of people? What happened limit x approach to 5? That'll be 1. Because limit does exist, but evaluation does not define. Because the open circle, yes, open circle because there's no evaluations. Do you see why this can cause confusion for a lot of you guys? Make sure you understand something. If I ask you f of something, you're looking for at that x value, you're looking for if you see any black dots. And that black dot is your evaluation. If you ask your limit at a particular point, you gotta reach both ends. If they come in both on the same open circle, then that's evaluation. Even on a closed circle, they be same evaluation. Yes, Omar?
What if it's the opposite? Like, what if we want to find the limit and it's a closed circle?
What?
Does that matter?
What'd you say?
What if we have like a limit and it's a closed circle? Does that matter?
It doesn't matter because let's just say if limit x approach to 3 in this case, it's gonna be what? 3. No, the limit approach to 3 is not 3, sorry.
Oh.
It's 2. But f of 3 is also 2. So therefore, we're going to talk about this is actually a continuous function. Yes, Simon?
Can you explain the 7 and 8 again, please? So I kind of don't understand.
Okay, 7 and 8. Let me explain that.
Like why it's like approaching from left side is infinity, but approaching from right side.
So from the left side of -4, if I use a tracer, right? If I use a tracer, I'm going up like this. It's going to infinite. And if I have a -4, then I should look for both ends. This going to negative infinity, this goes positive infinity. Therefore, it does not exist. They're not reaching the same value. Huh?
Will number 7 be undefined?
Number 7 is not undefined. Number 7 is going to the positive infinity.
But it's nothing on the same time.
Yeah, but it's -4 from the left side. That means I only look at one perspective. -4 from the left side is going up like this.
-4 from the right side isn't it one perspective?
-4 from the right side is going to be negative infinity. So if I would ask you limit x -4 from the positive side, that's going to be negative infinity. But if I ask you -4 in general, that means you need to look for both ends. That becomes, does not
So
exist.
what happens if it's like, would it be undefined too if it's x to positive? You just put, or is that just regular 4?
Where?
Like you put, I mean, if it was from x, if it's the x like towards like negative, it's from the left side, right?
Which value? Which value are talking about? X. Which value? X
Like,
equal to what?
For 7, it's coming from the left side because like negative, right?
Yep.
But then if you put like from the positive, would that be just one side as well?
Yeah, that's one side because if I say that positive right here, then that's going to be negative infinity because it's going to go down. Okay. One more thing. What happened when limits x approach to negative infinity of this case? 12. What happened when limit x approach to negative infinity? Nathan. I didn't call you yet. Nope. Yuri? Be confident. It's okay to be wrong. Nope. Sydney. One is correct. Good job. Do you know why it's 1? Yep. It's going to go toward what? The asymptote. And this asymptote is 1. The output is 1. Do you see that? So that's 1. Yes.
Negative infinity, it's approaching from the left. Or it's going.
Approaching, you start here, right? You start, oops, that was bad. You start from here, going this way.
Why did you start over there and not all the way from the right?
Wait, what is this? What is that?
Why not?
Huh? That's a way out? That's a pretty weird way out. Let me try other thing. Oh no. Don't allow. You'll hear me cursing. What happened to the laser? They used to have a laser. I hate it. Now they don't have it anymore.
I think is it not?
No, they used to have a laser that you can write if you hold your pen in there.
I think they still have.
They still have it? I don't see it. Yeah, they don't. They have this stupid laser now, unless there was different laser. Oh, they do. Wait, I want a tail. Oh, yeah. So if I go in this way, that's gonna be positive infinity. Oh yeah, I have. There's a tail. No tail. Questions? Yes.
How come? Why didn't we start off with the right all the way to the right with negative?
Negative infinity?
The number tool. Like you know how we started off from the one with the asymptotes?
Yeah.
How come we didn't start off from like the first one on the right?
Oh, so from approaching here
All the way to the right.
all the way to the right, because if you have a negative infinity, you're gonna start the most left hand side of the graph, and then you're gonna go to negative infinity, because that's the only thing matter, because there's so many gap in between. There's no point to start all the way to the right if you go into negative infinity. Yes.
Can you go over 4 and 5?
4 or 5 again. So 4 says -1. Wait, did I erase that? -1. Limit approach of -1, that does not exist, because if you reach from both sides, -1 is going to be 2, 1 is going to be 4. So that would be does not exist, because you had to look from both ends. And number 5 at 1, it's going to be a solid dot, but again, it's not reaching the same value, so therefore does not exist. If I ask you one value, you should look from both, like both ways, see what they come up to be. Are they come to the same conclusion? If I ask you one way, then they can define something. Yes, Kevin?
But if the line connects, positive one, then it will exist, right?
It will exist. For example, at 3, if they connected like this, the limit x approaching 3 does exist. Does that make sense? Okay, so today just understand that evaluation. Questions? Okay, then we're going to talk about the first power limits. I'm going to start with basic limits. The basic limits x approach to c of b is equal to what? What happened when limit x approach c to b? Now, a lot of you guys don't understand the question. Now, for me, like I always thinking about graphic approach. That's the best way to think about it. Limit x approach c to b, what do you think is equal to? A. Nice try. No. I don't know where A come from, but what do you guys think? Alvin? B is correct. Now, how did Alvin come up with B?
Or like limit of like a function's f of x, and f of x is like always y. So it's like when you approach the x value, the f value within b. So you use that to find b, which means the limit of whatever it is.
Okay, Alvin, you had a good reason. Good job. So usually this is f of x. What he say, that's f of x. F of x is also known y. That means y is equal to b. Now y equal to b, that means a horizontal line of b. So that means I have some type of horizontal line. We don't know what a b value could be, 2 or 3. Is it constant? So let's just say this is b. This is y equal to b. So it doesn't matter if I reach c here, the output is still b. So that's equal to b. That was a very good explanation. Good job, Alvin. Now c and b both are constant. Now this is the first basic limit. Second, what happened limit x approaches c on x?
minus 5 divided by x.
No,
No, what do you mean?
Simon.
Would be 0.
No. Landon.
Well, I think it's like x is like y equals x, so then you like you have a diagonal x.
You start on the right track, and then what? So what do you think is?
X also.
Shh. Come on, Landon. Simon.
Would it be like?
No. Omar.
Would it just be 1?
No. Kevin.
That's an excess.
No. Kevin, you're not thinking. Alvin.
Is that also just x? Is that not the same thing?
No. The answer is C. You think about it, right? If I have a graph, you guys all start with a graph. That's good. Y equal to x, the graph is going to be right here. Now pay attention. If you have x approaching to C, right? Now, sorry, this graph is really bad. So let me redraw that again. So the graph is going to be something like this. Right? So guess what? If I plug in C, it doesn't matter what a C is, right? The output is also C. Do you see that? Because that's C. It didn't matter because you plug in C into X, right? The output's still C. Does that make sense? Because
both ends and left.
it doesn't matter. Because if I plug in C into the X, I'm gonna get C. This is an example that, yeah, if limit x approach b of x is equal to b, because you plug in b into the x, the output is the result. The first one doesn't able to plug in because the function is b. The second one is x. One is a constant, one's expressions. Got it? Okay, and never, so last one, 3. When limits x approach to c of x to the n is equal to c to the n. Just plug in c into the x to the n. X to the n is a function. Plug in. The first one you cannot plug in because the first one is a number. There's no variable for you to plug in. Okay. Now I'm going to talk about property of limits. Now this one is I would say pretty intuitive. And what I mean by intuitive, just assume that they have two functions. That says assume that there is a function of f of x and there is a function g of x. Now if I limit x approach to certain value of f of x, I'm going to call it L. L is not a constant. Now you guys are going to understand the difference between constant and expression. L is a constant, A is a constant, B is constant, C is constant, X is variable, Z is a variable, right? So now if I have limit x approach to C of f of x, of g of x, sorry, of g of x is equal to k. So k is another number. So if you guys know, this is just a constant. This is a constant. This is a constant. So A, B, C, K, L, I hear they're all constant. The only time variable for sure is x, right? y is a variable. Now we're going to talk about scalar multiple. Is when limits x approaches c of a constant b of f of x is equal to BL. Now let's talk about this again. This b can be outside the limits because b is a constant. A, B, C is all constant, right? Is f of x a constant? No. F of x is the expression. They stay inside the limits. But since b moving outside, limit x approaches c of f of x equal to L, then therefore your answer is going to be BL. Okay, so like right now, the calculus part is is to understand the simple things. So the next one is called sum and difference. So x approach c of f of x plus minus g of x. What do you think is going to be? If I already define this equal to L, and if I define this equal to K, what do you think the answer is going to be? There we go. It's very intuitive. It's not something crazy. Same thing. Limit x approaches c of f of x times g of x. That's equal to what? Okay, good. So I would say the first is the most important one. If it's a constant, you can move outside. Fourth, limits x approaches c of f of x over g of x. That's equal to L over K. But provided K cannot equal to 0, why can't it cannot equal to 0? Because you've been defined. 5. Limits x approaches c of f of x to the n power, that's equal to L to the n, because we are reaching f of x, and that's equal to L, and that's equal to Ln. And that's some basic limits. So first thing about limits. How do we find limits algebraically? First thing is plug in the value. Always plug in the value. Plug in that x approach 2. So for example, and if you get a value, you're done. And I'm going to show you that example. Let's say limit x approach 2 at the 2x plus 6. Guess what? Just plug in 2 for x. What am I going to get? 10. Anybody can do this. A pre-algebra 1 student can do this. But unfortunately, I would never ask this question. But the first thing you plug in is plug in a value. If you get a value, you're done. You do not go any further. You stop right there. So sometimes you plug in the value, you get this result, 0 over 0. What do we call 0 over 0 yesterday? Indeterminate, not undefined, so indeterminate. Indeterminate has few different cases. And what am I mean few different cases? You got first case is called a cancel factor. So anytime you have cancel factor. Second, you have a radical. When you have a radical, it's something to do with conjugate. Three, if you got a complex fractions, then you want to combine fractions. Four, when you have absolute value, we'll talk later today that involve this. So absolute value is different. You have to choose to do one-side limits. And I'm just gonna give you. So we're going to talk about the first case. So this is an example of cancel factor. If you have limits x approach to, I don't know, 2. No, actually, 2. Okay, 2. X squared minus x minus 2. Wait, hold on a second. Plus over x sorry, let me give a better question here. Let me think of a better question. Let me come up with a question that's better. Okay, you know what? I'm gonna use this question because this is a dumb question. But this is kind of review something which is I can help you with. So it'll be x cubed minus 8 over x minus 2. What happened if I plug in 2? So 0 over 0, that means you're gonna do some type of math. Like do math, right? What kind of math? What can I do with this things? Well, we can start with first choice, cancel factor. Do you know how to factor this? You're supposed to know how to factor this from your review sheet. It's called SOAP. Yes.
X minus 2 times x squared plus 4x plus 64.
That was bad.
On 4x.
The 4x part is bad and the 64 part is bad. Sophia, do you know how to factor? X squared? What? Two x is good. But it's not plus 1 though. It's plus 4. Huh? Oh, okay. So x minus 2. So I factor the top. And guess what will happen when I factor the top? I prevent them denominator to 0 now. So that becomes limits x approach to 2 of x squared plus 2x plus 4. And then that's equal. Now I can plug in 2. So be 4 plus 4 plus 4. That's equal to 12. So any type of factoring is accountable. Any type of factoring is accountable. It could be a box method. It could be things. After you cancel, then you plug in. Because the only thing on the bottom is that x minus 2. If I reach 2 on the bottom, that will have a problem, right? Is that okay? Okay. So this first case is pretty easy. Second case. What happened? Limit x approaches to 0. Square root of x plus 1 minus 1 over x. What happened if I plug in 0? Huh? No, not undefined. 0 over 0. Indeterminate. That means I have to do some type of math. But can I factor that? No. But what can I do when we have radical? Conjugate. Now, most of you guys never had to rationalize numerator. This is the case that we have rationalized numerator. What happened at approach 0? How do you rationalize the numerator? You multiply the top by bottom or what? What is the conjugate? Can you tell me conjugate of the numerator is? Do x plus 1? No.
Oh, over.
No. What's the conjugate?
That's one.
+1. Thank you.
Oh.
But you have to do this because this is a ratio of 1. Now, let's show you how magic happened. Limit x approach 0. What happened to the numerator? Do you know what is square root x plus 1 minus 1 times square root x plus 1 plus 1? Do you know? Well, this is the x minus 1, right? X minus b and x plus b. If I multiply together, what am I going to get? A squared minus b squared. So it'll be square root x plus 1 square minus 1 square. Does that make sense? On the bottom, it's going to be like this. Now, what happened with this square? That's going to be x plus 1 minus 1 over x times square root of x plus 1 plus 1. Limit x approach 0. What can cancel? Well, the 1 can cancel first because that's -1 and +1. Is that okay? Can the x cancel out? That becomes 1. Now, can I plug in 0? And that's the radical one. So you're going to have to do some algebra question. You got to deal with radicals. And I'll make a video if you struggle with radicals. But tomorrow we're going to go to complex fraction.
So that's your 1/2 or is it?
Well, today is Friday, right? Huh? The answer is 1/2.
John. It's gonna. I thought it was a test.
I think it's test.
It is a test.
No.
Yeah.
Hi.
So, Mr. Ye, on Desmos, when we plugged stuff in,
Why are you not here yesterday?
what?
Why are you not here yesterday?
I was sick.
Why are you always sick?
I was sick?
Here you do.
What? I've only missed like 1 day of school.
This is the second day.
Second day. Yes, this is true.
Oh, true. I don't lie.
I agree. You did not lie. It's scary.
That's scary, like how honest I can be.
So for the first 7, you just wanted us to check it with Desmos?
Yep.
But how do you get the chart on Desmos?
I got you. I'll show you.
He will show you.
I got no, I have it.
Computer.
What?
I'll show you on your phone and your computer.
Yeah, I have it on my phone. It's just I don't know how to
Give me your phone.
get the
Okay.
exact numbers.
Oh, what do you mean? This? Just
Oh, you said that.
since you don't want you can't put the limit in there. You just put wherever it's listed.
So the 4 numbers that you or the numbers you already put.
Yeah, 0.9. Yeah, whatever you do. Those are the numbers you can plug in. Oh no, I was doing the trace because like I saw it and I was like, this looks kind of easy, and I was like, it's not that easy. And then I just like watched a video on it. Then I kind of. It wasn't fun.
No, I mean, sometimes like Which video did you watch?
I forgot what it was. It was also super late at night and there was a party going on downstairs for my family. So I was kind of just like knocked out. I went downstairs and like was gonna have a shot of vodka.
So let's put it this way.
Have a shot of
There's a lot of math video online, and a lot of them are not very good resource.
Yeah, there's
So
this one.
depends on the teacher. Like for example, I don't like organic chemistry tutor. I just think that he does very sketchy job. I mean, those people like it, but I think he's horrible. Now there are some people who are good. I usually recommend to people like Professor Lender is probably the best one in there. And if you ever want a loss or something, Professor Lender is it's a better video than I can do. I have advantage over him, don't get me wrong. But I even learned Calc 2 from him because in order for me to teach Calc 2, I have to reteach myself. Today. Why? The homework is really. All you have to plug in the desk. I told you that yesterday. I said the homework is plug in the desk. Just plug in a value until it reach. No, you don't have to self. No. You could have asked online. People would have helped you. I did. It was like 2.5. And like, I'll do it again.
Yeah, how does it feel to be the coolest guy?
I'm the coolest guy.
I would also say so.
No, I just think like, I mean, if I were you, I would think I'm the coolest guy.
Oh no, I never think it. I think I'm kind of corny, but yeah, I don't know. But I have true freedom because I say what I want to say.
They can't fire you. They can't fire you with your test scores.
Well, they can. They try.
They won't.
Trust me, they tried.
They tried,
They tried.
but they won't though because.
Oh, what happened is there was a student cheat in front of me. I told you this serious story. That they there was a story that he like I asked him a question and he didn't know, so he looked up on photo math and he do it on the board. He said, "Mr. E, I solved it." And that basketball, you saw that basketball just rolling around. I take a basketball and I chuck at him.
Desmos only. Nothing else. Only Desmos.
No. Okay, so I got an investigation for 2 years. They pulled me to like Tallahassee. Like, what happened? I'm like, the kid deserved it. It's like, I didn't even lie. I was like, did you hit him? I said, yes, I did. It's like, I didn't even fucking lie. I just be as honest as I can. The kid deserved it.
You don't. You you see with your eyes.
No. I asked him. I even asked him. Did you cheat? He's like, no, I didn't cheat. I was like, and then he did it first time, right? And the answer was so off. This is a pick problem, and he canceled the I. E equal to I over I plus G cancel the I, and it's also negative. He solved the problem. Like and then everything was right. And I was like, that's not cannot be possible.
Did he leave your
He's afraid to sign up my class. He's afraid to sign up my class.
He's afraid to.
Yeah.
Did he leave though? Did he like drop the body?
I say you're not only in disgrace, but you're not allowed to set a foot inside my door ever again. But he's not. The basketball didn't hurt because that basketball is soft. All right, but he was butthurt. He was way butthurt. I mean, I'm never gonna lie to the student. If I think you're good, I would tell you you're good. If I think you're shitty, I would say you're shitty. But I think you're improving. So I would say that. It doesn't matter who.
You don't even have to tell me. I already know.
All right, so shh. Yesterday's homework is not supposedly as hard as the same. Basically, you just plug in decimal of each value until you get really close to that value and see what the sum up to be. Like, are they close to what value? It's not crazy. You don't have to. You don't have to do any calculation. It just wants you to feel the number numerically approach. It's nothing crazy. It's not supposed to be difficult. It's supposed to be just plug in a value using the table. Tanner, are you paying attention to what I say?
Yeah.
Just had to plug in a value. Just had to plug in a value. Now, I'm going to come look at your homework. So, doing homework is a perk. If you don't do your homework, you can never retest if I offer a retest. Okay. Then you have to be like, I don't need a retest. Like, look, right? So, if you don't do homework, then you'll never get a chance. So you have to be able to do the homework. Well, from one test to the next test. So make sure you do. Make sure you put it on top of the homework. Make sure you try it. It doesn't matter if they are right or wrong. I don't give a shit about if you got it right or wrong. I give a shit you put in effort. Try the number. Even if you got everything wrong, I'm okay with it. I'm not gonna look at if you did it right or wrong. I was going through. I was like, wait, how come you only did question 7? But at least you got to question 7. I have no problem with question 7. He should have finished 8, 9, 10. But it doesn't matter. But he needs to start figure out, what's a number goes to. Numerical approach is the first perspective. I'm only asking you the first perspective. I didn't ask you to do algebra. I didn't ask you to do anything crazy. I just asked you to say, hey, how do you approach a number? Get used to use decimals. Decimals is going to be very, very friendly.
Mr. Yang. Mr. Yang. Mr. Yang, you just got an email from Tina Fey. You got an email from Tina Fey. Tina Fey.
Okay.
You got an email from Tina Fey.
I think that it was like it's on the one, so like I was working. I was like, I'm not sure.
You have to question value.
You don't know you're
I'm not asking you to do it all. I'm just asking. Josh, do your homework?
Josh, I'm gonna help him. I'm gonna sort it out.
I'm gonna jump in.
Yeah, you jump in and then I'll join you and jump in.
Wait, let's read it. So for 9, 11, 13, you're supposed to plug it in.
What?
For 9, 11, 13, you're supposed to plug it in.
Yeah, you're not supposed to evaluate. The teacher has to evaluate. No, I say that in the thing. No, that's okay.
What's on the agenda?
All right, so yesterday I missed a very exciting lecture for you guys. I'm so sorry. But yeah, I was talking about oscillation, but I do want to spend time to talk about oscillation.